Hi everyone, in this video I'm going to be talking about laws of chemical combination. So let's begin. Okay, so whenever we have any reaction in chemistry, so it's a very basic reaction which is written A converts to B, where A of course is my reactant and B of course is a product. Okay, so when any kind of combination, chemical combination or any chemical reaction takes place in chemistry, it takes place with respect to certain laws, and those 5 laws are called laws of chemical combination. Okay, well, unfortunately, chemistry is not this easy that there'll always be one reactant and one product. No, of course, we can have a number of reactants and a number of products which are formed, but any chemical combination which you see in front of your eyes is going to be happening with respect to the law of chemical combination, which we study in this video. So let's begin. The first law is called the law of conservation of mass. Okay, so what I'm going to do is I'll talk about the statement of the law, and then we'll discuss what the law basically means. Okay, so the law of conservation of mass states that matter can neither be created nor be destroyed. Okay, so I think the statement is something which is true for energy also, and we all know that, but what this statement actually means, let's understand. Okay, so for example, let's say you have a box, okay, and you add 2 balls into the box, because you have 2 balls, 2 blue colored balls, and you add it into the box which you have. Now you close the box, okay, and then again after some time you open the box. What do you expect? How many balls would you expect to come out of the box? Of course, you won't expect 1 ball, you won't expect 5 balls, because you added 2 balls, you would expect 2 balls to come out, right? This exactly is nothing but the law of conservation of mass, that whatever mass you put in, you expect the same mass to come out and nothing otherwise. Okay, so in a reaction which you see on your screen, this is a reaction which is very simple reaction. I'll just write it otherwise. Okay, so of course on the right hand side you see 4 oxygen atoms, 1 2 3 4. Okay, after the reaction, you would expect, of course, not 1, not 2, not 3, but 4 oxygen atoms to be present. Okay, so there are 1, 2, 3, 4 oxygen atoms, which is right. Okay, again on the left hand side, you see 4 hydrogen atoms, 1, 2, 3, 4, and on the right hand side, you see exactly the same 1, 2, 3, 4. Okay, on the left hand side you see 1 carbon atom, and the right hand side you see 1 carbon atom, and this is a right equation or a correct equation because all the masses are balanced, and this is the reason basically why we always balance all the chemical reactions. Otherwise they're not true. If we don't balance the chemical reaction, they're not in line with the law of conservation of mass, and they're not correct. Okay, so because of this law we can also predict the products of some reactants if we know the amount of the reactants, and of course we have to balance all the equations. Okay, moving on, we have the second law, which is the law of definite proportions. Okay, so let's first see the statement of the law. A given compound always contains exactly the same proportion of element by weight. So I've written weight in a different color because you will see why in a while, but this is a very important law, and you have to just first read the statement and then we'll understand how. Okay, so a given compound, in this case I will talk about a compound which is water. Okay, water is H2O, everybody knows what water is, contains exactly the same proportions of elements by weight. So water is having 2 elements, oxygen and hydrogen. Okay, oxygen of course is 1 and hydrogen is 2, right? So the ratio, if I say it is oxygen is to hydrogen, is 1:2. This law is basically saying what? For example, you have a glass of water which you take out of the refrigerator of your own house, okay, and your friend who's sitting in Germany, let's say you have a friend in Germany, he or she also does the same, and they get a glass of water from their refrigerator out there in Germany. Okay, irrespective of the source of water, the water molecule is always going to be 1 atom of oxygen and 2 atoms of hydrogen combined. Okay, so this is always going to be the composition of water, irrespective of the source of water which you have. So these 2 waters are from different countries, but they could have been from any different 2 places of the world. Okay, but water is always going to be having 2 elements, which is hydrogen, okay, and oxygen, combining in the ratio 2:1 and nothing otherwise. Okay, so irrespective of the source, any element, when 2 elements combine, okay, to form a compound, they will always have, the ratio is going to be always the same. Okay, so I hope you get what I'm trying to say. So after this law, this next law which we have to read is the Gay-Lussac's law of gaseous volumes. Okay, so this law is nothing but exactly what we read in the last slide, which is the law of definite proportions, but by volume. So you can see I have highlighted the word by volume here. Okay, so that law talks about ratio by weight, and this law talks about ratio by volume, and everything else is exactly the same. Okay, so the same example can be used here of water, but now we'll talk about the volumes instead of the weight, and everything else is going to be the same. Okay, the next law which we have is law of multiple proportions. So let's see what this law has to say. If two elements can combine to form more than one compound, okay, the masses of one of the element that combine with the fixed mass of the other element are in the ratio of whole numbers. So I think I just read a script. Okay, so let's understand what the script actually has to say. So if two elements can combine, two elements, let's say I am having hydrogen and oxygen, the same example I'm taking, okay, to form more than one compound. So hydrogen and oxygen can combine to form water, we all know that, but they can also combine to form hydrogen peroxide, which I guess if you don't know, you should know it now. So H2O2 is also something they can combine to form, and H2O to sabko pata hai, I guess. Okay, so H2O and H2O2 are two different compounds which can be formed by this combination of the same two elements, hydrogen and oxygen. Okay, the masses of one of the element that combines with the fixed mass of the other element. Okay, so these two, H2O and H2O2, what do they have in common? They have H2 in common. Two atoms of hydrogen are in common, right? So the fixed mass in this case is H2. All right, and then what is the other element? Of course, oxygen, right? So the masses of one of the element that combine with the fixed mass of the other element are in the ratio of simple whole numbers. So here in this case, the fixed mass is hydrogen, so the left one is the other one, which is oxygen. So if I compare H2O2 versus H2O, okay, so fixed mass is of course hydrogen. So if I just compare the ratio of oxygen atoms, it is 2:1 in this case. Okay, so this law is basically saying it cannot be 2.5:1, it cannot be 1.5:1. Okay, it will always be 2:1 no matter what. So the next law is the Avogadro's law. Okay, so the Avogadro's law states equal volume of gases at same temperature and pressure should contain equal number of molecules / number of moles. Okay, so what this law is basically saying is that, for example, if you have two gases, let's say there's gas 1 and gas 2. These two gases, the first gas is at pressure P1, volume V1, temperature T1, and the second gas is at pressure P2, volume V2, and temperature T2. Okay, the law is saying if all these three variables are same, that is pressure P1 is equal to P2, V1 is equal to V2, and T1 is equal to T2, then definitely N1 or number of moles of this gas must be equal to number of moles of the other gas. Okay, we all know this equation, PV is equal to nRT. This is the equation of ideal gases. If you don't know about this equation, don't worry, because in the next chapter, which is the gaseous state, you will know what this equation is. So stay tuned for that. So if you know what this equation is, if I just put the first gas, which is P1, V1 is equal to nRT1, okay, and divide by P2, V2 is equal to nRT2, okay, and as I already know, T1 is equal to T2, V1 is equal to V2, P1 is equal to P2, and R is the gas constant, they are same. So this states N1 upon N2 is equal to 1, which means N1 is equal to N2. So I mathematically proved it that if the pressure, volume, and temperature of two gases are same, then they will definitely have the same number of moles, and if they have the same number of moles, they will have the same number of molecules. And that's all. Okay, so this is the Avogadro's law, and if you have any doubts in any of the laws which I just mentioned, so definitely you can ask me okay, whenever. And thank you so much for watching, and stay tuned for more.